Hello everyone and welcome to this GSMA IoT web talk. Today the topic is getting to smart, deploying and operating 5G IoT for Industry 4.0. So my name is Jo Gilbert and I'm a technical director and the manufacturing lead at the GSMA, and I'm delighted to be welcoming three speakers today on the topic. So we'll be welcoming Stephan, who is the Vice President for Mobile Network Testing at Rohde Schwarz, Fawad Noory, the Senior Director, Private Network, Consumer Electronics as a Service at Core Wireless, and Stephane Gervais, the Executive VP for Strategic Innovation at LACROIX Group. And I'm really looking forward to hearing what our colleagues have got to say today. So to take me to the agenda, first of all, so after I've spent a couple of minutes introducing, I'll be handing over to Stephan from LACROIX, who will be talking about 5G IoT for manufacturing, from testing to IoT Continuum proposition. And next, Fawad from Core Wireless will be asking the question, are manufacturers hesitant to move to 5G, from trials to testing in brownfield and greenfield environments? And last but not least, Anne from Rohde Schwarz will be talking to us about how network testing ensures 5G private network, ensures 5G private network performance. And then towards the end of the session, we will have 10 minutes Q&A. So if you have any questions throughout the session, please do add them into the chat. Okay, so before I hand over to Stephan, I would like to just take a moment to mention the 5G IoT Manufacturing Forum to those of you that may not be familiar. So the forum is a global community of manufacturers, network operators and the wider ecosystem that are coming together with the aim of pinpointing manufacturers' challenges and opportunities and identifying how 5G IoT can address these. And then we're working together to encourage sharing of best practice and partnerships and proof of concepts, etc. Over the last year or so, we've covered a number of topics which are listed here for examples, and we've got a number of papers and case studies that are available on the GSMA website. So if it's something that you're interested in getting involved with, please do get in touch. We'd love to talk to you about coming to join us in the forum. Okay, and actually also a quick plug before I move on to the first of our three speakers. We're delighted that this year at MWC 22 we'll be holding a manufacturing summit. So there'll be three 45-minute sessions on Monday the 28th, and that's going to be including three sections. The first is advanced analytics and robotics for 5G IoT and manufacturing. The second is focused on private and dedicated networks in Industry 4.0. And finally, we'll be looking at kickstarting 5G for manufacturing. And there is a link there taking you to the Mobile World Congress Manufacturing Summit site. I think for everybody that's live on this session now, I think that can click straight through. Otherwise, I have a QR code coming up for anybody that's watching on the video catch-up. Okay, so last slide from me. So just a quick reminder of those various links to our web page, our email address, and also the Mobile World Congress 22 site. Okay, so enough of me for now. Without further ado, I'd really love to hand over to our first of three speakers today. So Stephan, if you'd like to take the lead.
Yeah, thanks very much, Jo. Hi to everyone. I'm very great to be here to share what we've done with 5G and to give you more hints about what we do at LACROIX and what we're expecting about 5G as well. So my topic today is 5G for IoT and manufacturing. Before I go to what we did, I just want to for you to understand what we are doing in LACROIX. So we are, I would say, a mid-cap company, about 450 million euro revenues this year and 4,000 people. However, we just acquire a company in North America doing manufacturing. So all these numbers have changed, and I don't have the latest update on this one. So our main focus is really electronic manufacturing, EMS, where we do design, but we mainly do manufacturing of assembly of electronic boards, PCBs, and everything for automotive, aerospace, and healthcare market, and industrial as well. We have manufacturing in France, Poland, Germany, Tunisia, and now North America and Mexico. We do also have our own product lines, doing a lot of IoT for smart city and smart environment, meaning for water, networks, and smart grids and everything. But this is not our topic today. Hey, the topic is um, our brand new, we say not running yet, our brand new manufacturing plant in France, which called Symbiose. That we are going to, we say, finalize it in the next few months. We had a bit of delay to move from the old factory to this brand new one. And what we wanted to do is to have a much more innovation in terms of industrialization of manufacturing. Since we have, we say, a kind of greenfield possibilities, which is very rare, been very, very long time, many years that we have not done this in France. I mean, the electronic manufacturing market there. So we wanted also to be sustainable and to innovate in terms of environmental. Again, we have done a lot of things in terms of energy saving, of course, but also sustainability for sure. But also to work on social innovation with our worker and to make we say, the job much more attractive and to keep our job in France. The vision, from the vision we had, then now we are in action because the building is finished already. Everything is done. And what we have deployed in terms of automation and digitalization, we try many things to improve what we have done today in our old factory that you can see on the bottom left, right? In order to make sure that whatever we test, we can validate all these tests when we move to the new factory, which is almost ready there. It's going to be, as I mentioned to you, in a few weeks' time, we're going to start to move the machine. However, we don't want to. We need still to make a production every day. So we have a minimum description about the manufacturing. So we try many things about cobots, about augmented reality, about IoT platform, IT architecture also has to be completely redone, and all the digitalization process also. So that's why. We had the opportunity to try new technologies, and 5G was definitely one of them. Just to give you some numbers, this is a 25 million euro investment. So just for the new building and for the moving, right, all the machines and everything are not part of this investment. So 25 million euro investment. We will have a 6 SMT line, so which is in parallel, of course. And we are using 18 partners for to help us to build this new factory. The number you can see in terms of people, in terms of revenues we're expecting, is a ratio about we are going to keep the same number of people. And even though it is moving from 68 million euro to 100 million euro, our real target is to double the revenue per people. And this is a necessity for us in order to keep the job in France, and is to be way more efficient and to get a way more bigger ROI on this new factory. So this is, I would say, our great and biggest challenge so far. So let's go straight to 5G use case that we experiment, and we have done, and we have done this in cooperation and partner with Orange. Orange, because we have been one of the first two industrial site to have the privilege to get a 5G. The other one is Schneider. The use case were not too much on the, we say, high frequency, I mean, say high bandwidth, sorry, but more on the massive IoT on one side and the reliability of a 5G on the other side. So the first part was pretty, I would say, simple. That's the one you can see on the bottom left. Is what we have in this wireless, secure, and a real-time factory. What we have done on this one is to make sure that we compare all the technologies and we can get a benchmark of a 5G compared to what we have today, which was at that time LAN and Wi-Fi. And 5G in this very noisy environment with a lot of machine, a lot of, I would say, RF, I would say, parasite, behave really well compared to the other technologies. So this was the first part of what we have done, and was definitely, I would say, a good benchmark. What we've done, and let me play the animation, is better. After that, and in parallel, it's we use our one of the existing product and we move it to, we say, a 5G connectivity. In order to this product is here to manage the HVAC of our manufacturing. So manufacturing in electronic, you need to have a very precise temperature control in every room, and humidity as well, because of components, because of all of that. And this costs us millions of euros per year in terms of power and in terms of electricity. So what we try to do, and we have done successfully, by the way, is to display and to get a lot of sensors all across the full factory. So we get a very accurate knowledge about the temperature and humidity. So we can control very accurately also when it needs to be done in terms of producing the heat or the aircon as well. And the target is to get it to a saving about 30 to 40% of our energy saving. And thanks to the fact that we can display and get easily connectivity with a lot of sensors with a 5G. So it was, I would say, pretty successful, I would say, test we conducted it there. And we want, of course, to repeat this one and to even get this use case repeatable for any other type of factory or even buildings as well. So the next one is pretty another one which is very nice. This is the AGV, this automated guided vehicle. So we do have this AGV going from one floor to another room, and these guys are having this good but not that smart, right? If there is anything wrong on the pathway, or is there anything to modify, you need to reprogram the engine and the AGV. So the idea here is to make sure that we can remotely reprogram it, and we can also make him avoid some, I would say, some obstacle on the way, and this AGV is not stopping there. And for that, we need, of course, to have 5G, and the low latency of 5G is even better if you want to take back the control manually, and also to get a fast way to update this AGV as well. The next one is this automated optical inspection. This is another one where we have I would say, too much false positive type of defect, meaning that what to do in terms of we say visual defect, the camera which are there, or any kind of even a wrong defect, we need to retest after with some people. So meaning that we have a lot of manpower which are wasted for such, we say, not very exciting task to recheck behind the camera. So the use case here is to get all this data and to get artificial intelligence in order to reprocess all of that for having less false positive and to decrease the manpower that we need to recheck all the boards and all the PCBs as well. To move on, and another use case, we are already using some augmented reality. So again, we are in industrial. Augmented reality for us is not to get a goggle, right, which is not practical for our operators working many hours with that. What we do on our augmented reality, we have projected augmented reality on the desk, right? So and this is guiding our operators to how to assemble each piece of the PCB there. However, it's not really working well with Wi-Fi and everything. It's pretty self-contained. We want to add this 5G so to assist in the real time all the operators to update also, but also for all the training as well. So what are we doing? Why are we doing all of that? And this is more now a hope rather than experiment on the 5G. What we want to do have, and what we need to have in our manufacturing plant, the new one, we need to have a secure and real-time monitoring of all the factory. The dream is to get a digital twin, which is still very difficult to have, in order to to simulate all the operation floor and to readapt over time the operation floor because we have a lot of different production with a different way of setting up the manufacturing plant. And the new one, we can even move a machine, which was not the case before or was very difficult. So we can even optimize this process. So it's a lot of things on this slide, and I'm not going to talk too much on this one, but we have a lot of expectation there because we need to have this flexibility and adaptability all the time. So we need this wireless, a kind of technology that can be reliable, low latency, and sometimes high bandwidth, but not all the times, of course. With the speed, because decision, we talk about milliseconds just to assemble some PCBs and boards. So we need the speed of decision, and we need to make sure we don't break all the flow of material everywhere. We need a reliability, of course, with a security and quality, and we are also thinking about having a redundancy in terms of communication technologies as well. Dynamic automation, that's maybe say a strange way to say that, but we need automation, but this automation needs also to it's not something but it needs to be flexible, let's put it this way. So that's why it needs to be dynamically changed as well. And for that, we need to know what you need to change to simulate, and from this simulation to go straight to the implementation on the operation floor. Maybe some, I would say, it's not a dream, but what we want to do also is to transform the full value chain. If we know all the information and the data in our about the supplier, about our customer, and maybe even the customer, then we are able to change the full value chain to go down a just-in-time with the right amount of investment and money in terms of cost for everyone. So this is something which is only possible if we have all information from the supplier to the customer. The outcome technically is that we believe that 5G network must be hybrid for us. Then we need to have an operator because it's way too much complicated for us to manage our private network. However, we need to have a dedicated band that are only for us for some security reason and reliability reason as well. And it's something we validated with Orange. It's something they can do as well. So this is fine with us, but we need definitely this hybrid 5G network. However, something we saw is it's very challenging to go from 5G and to get 5G IoT device, and prototyping at that time was very difficult. So, and I'm not going to spend too much. What we've done with Orange is to say, okay, fine, we have 5G networks. However, it's too difficult to do prototyping, and way too long to go for industrialization and deployment. So we get a partnership type of offering, which now is open to everyone, with Sierra Wireless and ST Microelectronics to get the full value chain from prototyping to deployment of IoT devices with 5G. And we started with the LTE-M so far. And this is done in 3 steps. And as you mentioned here, the prototyping on first one, the second one is a proof of value. And the last one is deploy and industrialization of scale. And as you can see, we have few days to get the prototyping, 4 to 12 weeks for the proof of value. And the industrialization is 12 to 24 months, 24 weeks, sorry. This was really necessary for us to drastically reduce that in order to use the 5G and any kind of new technologies for industrialized application. So that's all from my side, but I think we have a Q&A at the end anyway. Thanks very much for listening. Joe?
Thanks so much, Stephan. That was really great. I think it was really interesting to see how revenue predictions are going to be increasing, whereas in the new factory, the size of the factory, the headcount stays the same. I think that's really fascinating, and also great to see through the IoT Continuum, the partnerships. And I think we see this, I think I say this a lot actually, but the partnership element seems to be a really key theme in all of this 5G IoT manufacturing arena. So thank you so much for joining us today. And yeah, as Stephan just said, there is 10 minutes Q&A at the end, so please do add any questions into the chat. Okay, so let's move on then to our next speaker, and I'm delighted to be welcoming Fawad Noory from Core. So over to you, Fawad.
Thank you, Joe. Great presentation, Stephan. Very enlightening, and it's really good what you actually touch on. Few things I will be taking a little bit further on, but those were the right points I think you mentioned. And good luck with the journey. Looking forward to more exciting news from your side. So my name is Fawad Noory. I'm part of Core Wireless, focused on private networks and product management for developing the solutions in private networks. A little bit on Core Wireless. Core Wireless is an industry leader in IoT. We deploy, manage, and scale IoT solutions for our customers. We work with our carrier partners. We provide coverage up to 190 countries. We have around 1,200 connected devices in IoT, which we support our customers in either it's our tracking on fleet management or medical devices in various shapes and forms. So any questions, please let us know. We'll be happy to support you in any your IoT challenges. And this is also relevant into the private network, because the private network in manufacturing is all about connecting devices in industries, and that's where it's all about IoT. So I will continue this and focus on the agenda that we have today. Let's talk about industrial IoT and 5G. So industrial revolution has various stages, and I think everyone knows about it. So where we are today with Industry 4.0, initially it was researched and published around 2015 with focus on 6 design principles: interoperability, virtualization, decentralization, real-time capability, service orientation, and modularity. So those were the key principles that were when it actually came out back in 2015, and how 5G is keeping and making it more than just, it's actually making it much more robust now. Means the things that we can imagine within Industry 4.0 is it's marrying the physical and the operation with smart technology. Words like, I think technologies like machine learning, data analytics, we'll be able to collect so much data that we would not be able to collect before. And having access and the ability to deploy 5G enhances further on. And I'll touch base on those few things. Looking at where we are today on the private network, means how it is disrupting. And I think Stephan brought up great points on before me, and there are few leaders that they have already adapted 5G in different shapes and form, and there are few that are still navigating the journey. So looking at today's world, in I would say majority of them, there are other technologies that are prominent. Wired technology has been more robust and it's working. 5G is reliable. It is a technology that can provide that reliability similar to close to a wired connection, but it's not there yet. I think there are many challenges, and a few of the challenges were we heard before. Device ecosystem maturity. All industrial devices cannot be just lift and shifted. So there has to be a gradual, slow growth and development to have those devices to be built out. Not just building the devices, but also adaptation of the devices. I think those challenges will we continue to face in 2022, and by 2023, as the maturity evolves and the use cases and the return of investment in those benefits are cleared out, that will enable large expansion and adoption of 5G, and specifically private networks in the manufacturing space. So 5G will become as easy as Wi-Fi. Today, uh, I think there are challenges. It's not just the challenges of how 5G is. I mean, the technology experts would say, I know the technology very well, and the Wi-Fi experts or the wired expert, the industrial manufacturing, it's actually the adoption journey. It's not so easy. Things are evolving. I think there are ways that can make it much more easier. And I see some questions popping up. We will address those questions at the end of the call. And please be free to ask any further questions you have. So challenges. Let's look at there. So this journey that is being depicted in this slide is generally very much familiar with the telecom operators. For expansion of a network or even a greenfield deployment or a brownfield add on certain components in the network, every operator or every radio technology goes through these movements. They do a deployment planning, they do a site survey to see, can I actually put my equipment? Can the equipment that will be handed or being installed in certain wall, can it take the weight of the equipment? Or it will be a street pole light or indoor area structure, can it take the weight of that? And then does the network design provide me the proper coverage? Not just the radio coverage, but also can I, as I add more capacity, either it is an IoT devices or AGVs or further devices that we haven't even thought in the industrial space, or adding PLCs that will be running on 5G, can those still be having the capacity to access the network? So all these elements an operator goes through and they create a final bill of material. But the challenge where is happening is that operator does it iteratively. This never stops at an operator's work life. It continues. Most of us that are in the call or those that are in the industry, in the telecom industry, they know that an operators go through the cycle many times for a specific geography or even a specific location, to add on more capacity, to add on more coverage, to add on more devices, to support more devices in that area. So for a manufacturing, looking at 5G from that lens, it becomes a bit trivial. It's not so easy. It's not just putting it out and forgetting it. They need to understand also, for a manufacturing point of view, it's like this is an technology that is as elastic and expandable as they would want to have it. So just putting a 5G technology for AGV today, and in few years or few near-term future, there will be more devices that, so adding more capacity would require this cycle to be going through again. I will not go through all the elements of it. but we're happy to address any questions if you have. Um, just sharing it that today, even with 5G, we still bound to these elements. There are ways that are innovative ways that are coming up, how to actually address it and make it more seamless journey and make it more easier for manufacturers, not just for the manufacturers, for those that really see 5G can bring the benefit, but they don't want to go through the hassle of it. They want to see the outcome. They want to see what would be my ROI. How can I improve the productivity? How can I improve my flow time elements that will be critical for my production? So, uh, so I would say things are getting better and better, but we still are not there yet. Here, I think I'm going to take a few minutes in this slide, talk about few of the identified use cases in the industrial space and different geographies, and then also compare them a little bit, because I think I'm not going to take all of them, but compare them to give you a perspective when a manufacturing is looking, and if it's a logistical warehouse and they are looking for coverage, because coverage becomes very critical in a logistical warehouse to actually trace and track everything. They want to make sure that they have good coverage of the technology. And that coverage today, because of they would be putting more sensors out there, the data requirement, the data throughput is not significant. And if we look to a chemical processing plant, I'm looking at various sectors, I'm taking an example of chemical processing plant, they would have more rigid machines that are not movable. So that means the coverage once it's done is good. But in future, maybe there would be more robotics could be introduced, and then coverage becomes more critical. So for a manufacturer or anyone looking into these key elements, either it is latency, the device, or that capability requirement, or the coverage, they should be looking more elastically, because one use case of an AGV doesn't justify to have a 5G. I think there would be required more use cases beyond AGVs. And that's where Industry 4.0 and expansion with adding more IoT that can both be for coverage, latency, throughput, reliability element, and you add more and more capacity. What 5G brings, and I was discussing with one of the customers where they had few use cases, and by analyzing it, we concluded that it's only using 20 or even less than 15% of the capacity of the 5G ecosystem. And this is not about spectrum efficiency or about it's actually the capacity of the technology. So any manufacturer looking into adopting a 5G, they need to look at it as a journey. So it's going to be a journey where you will start identifying more and more additions of technology that you want to put on the 5G, so they can actually start using more and more. Either you do it in a whiteboard where you say, okay, today I want this thresholds to be met, this ROI to be met, or you looked at, I will do as others and few leaders in the industries are doing. They're doing trials and testing. They are trying to validate how technology would mix and match with their own ecosystem. So coming back to Industry 4.0, I think we know all for the fact that what are the outcomes, but also what are the key capabilities that Industry 4.0 bring, but also how what needs to be driven towards what outcomes. It means data-driven design, data as a service, real-time visibility, predictive maintenance, inventory planning. These are key for Industry 4.0. And how to match them to 5G. What are the outcomes? Outcomes: cost and time optimized design. For data as a service, we look at enhanced understanding of the customers and the operations. Real-time visibility, reduced downtime. Predictive maintenance, I think that due to collection of data at real time becomes much more significant. And that brings us to making predictive maintenance so that we have not zero downtime, but less downtime while keeping our operations running. Inventory planning, industry has, in the ecosystem, the industry has been quite mature in trace and tracking in public network. Now, the trace and tracking is coming into indoor elements where they even want to have their handheld tools to be traced and tracked or geofenced, just to ensure productivity, just to ensure usability, to increase the usage so they don't see their assets continue to be utilized to the optimal usage that they have designed it for or they procured it for. And those capabilities is where 5G brings in, and I'm not going into the technology, but bringing in the elements to it. So adding 5G to it, this is my second last slide. I'm just going to take a few more minutes into this because this becomes more crucial with the experience also in the brownfield and the greenfield deployment of manufacturing. It always comes back to who are the trusted partners? What are the trusted elements that you have in a group and an ecosystem? As Stephan mentioned earlier, creating a right set of partners and help that partner can navigate and guide through selecting the right path to achieve something like data as a service or even predictive maintenance. Right technology is also required. By right technology, I will mention a few things in this space where certain technology components on the radio technology, physical radios that were built for some other purpose were used in certain industrial ecosystem that were not built for that ruggedized ecosystem. So it's good to have the right partner so that right technology is used. And the same thing goes if it's in the right technology. Does it benefit to use an ORAN based, open RAN based technology, or does it benefit to use a proprietary full enclosed based technology? And it has its own benefits and drawbacks. I'm not going to go to that, but then I believe the right partner should be able to guide you. What are your key requirements are today, based on your operations, based on your work, how that will evolve, what are the device ecosystem lifestyle looks like, and how the technology lifestyle ecosystem, the OEM, the technology that you will select, how that is evolving. Those are the key points. Yeah.
I'm sorry to interrupt. If we could move to the last slide, we're pushing it for time, but
Sure.
it was fantastic. Any questions about this, of course, as we've mentioned, we'll capture them. And if we don't get a chance to capture them at the end, we will be putting them into a blog afterwards. So apologies to interrupt you, Fawad. Back over.
Thank you, Joe. Thank you for keeping me on time. So last point on the clear ROI, I think this we have to create clear ROI, and this is what the benefit would be to actually see what the clear ROI today is, or doing just a whiteboarding session to come to those clear ROI. So next slide. And be free to reach to access our download the ebook that we have, and I'll leave that. I'll just paste the link on the ebook in the chat window. Over to you, Joe, and thank you very much for listening, and thank you for your time.
Thanks so much for that, Fawad. I think everybody was very engaged in that, and it's really interesting topic. There's loads to talk about. I think an hour is never long enough for these. So, but without further ado, then I'm going to pass straight over to Anne. So, Anne, over to you. Thank you.
Thank you, Joe, and welcome everybody to this session. Thank you, Fawad and Stephan, for amazing presentations. I think our presentations fit very well in the order together. So my name's Stephan. I'm from Rohde Schwarz. We are a family-owned, internationally operating mid-sized company, I would call it, based in Germany, with an expertise in test and measurement, not just in the wireless ecosystem, also beyond. In cybersecurity, we have a lot of expertise. And one focus we are having specifically these days is really looking at how our measurement solutions can help to drive industrial development and also the productions. And we are also owning a couple of production lines ourselves, gives us a lot of opportunities in testing our measurement equipment there as well. So I will not go too much into the details on the business and mission critical use cases for the private networks. We heard from Fawad and also from Stephan a lot about requirements coming from the collaborating robots and also the AGVs. They require low latency, which comes by the technology 5G. But also if you look at a port scenario where you have a crane that's getting remotely operated with a lot of HD video cameras, you can imagine about how much data and how much throughput you would need to have such a scenario operating when we talk about communication. There are many more use cases. I think all of you are very well aware of that. And it's not just that we are talking about potential use cases. Also, the presentations before showed this is reality today. We are seeing, I collected a couple of press releases, what's just ongoing in Germany in the area of private networks and how many different industrial use cases we're already having today where 5G networks are going to getting deployed and are going to getting used. So talking about a 5G network, it's also about how to ensure performance of a 5G network. And before coming into the industrial networks, let's have a closer look. We have mobile networks all around us, and the aspect of testing and ensuring quality and performance of a network is not new. So let's have a look how this is done in a traditional mobile network first, and then let me highlight the aspect that comes in if we talk about the private networks. So this is what we call a network lifecycle. It's something that is repeating with every technology that's newly coming, with every key feature. So from the network engineering phase throughout operations and installation, this is important for the rollout of a network. Then you're moving into a phase when the network is already deployed. You have to ensure the benchmarking. You have to ensure the coverage in all the different situations. You are optimizing the network. And also you are monitoring the network. And for this life cycle, there are solutions available, and this is done at every mobile operator today. But when we want to measure and when we do talk about the quality aspect specifically to it, so what is important to measure the quality? And for the quality it's easy to have a single score that you can compare. That is on the one hand technology agnostic, but this is also something that is very transparent, how it's generated. So everyone can claim to say, we have the best network, but how to prove this and how to compare this? So we invented what we call a network performance score. And how is the network performance score done? So the network performance score is based on the quality of experience of a user. So you and I, we are typical users of a traditional mobile network. And what are we doing with our mobile phones? We're doing phone calls, we do video streaming where we need data, we are active in social media. And where are we doing that? We do this at home, we do this while driving. Everyone for sure has experienced a call drop while driving. We are doing this while we are walking on the streets or wherever we are. So in different locations, we have typical user behaviors. And the way the network performance score is discovered by this is doing exactly measurements and collecting data for these typical user scenarios in different locations. And all of these results are going to get put together. They are weighted. Also, the topology of a region is taken into account. You can imagine in a rural area, you have different results, different measurement challenges compared how you are having in the city area. You have different reflections and so on. So the results are weighted according to topology, are put together, and the outcome is a single score that's also approved by ETSI. So with that single score, it makes it very easy to talk about quality of a network and also to compare the quality. And let's keep that in mind and have a closer look. when we are talking about network in a private environment, so in a factory environment as an example, what are the challenges we are having there? And those challenges are probably different towards the challenges that we are having in a traditional mobile network. So one of the challenges for sure is there are a lot of reflections. If you imagine a factory, many metal interfaces are there that are putting reflections. And you have machines like the power switching units. They cause additional interferences. And if you imagine the devices that are connected, the antennas typically are also inside the devices. They are shielded. So all of this is being an environment that is not ideal when you talk about wireless communication. This puts additional hurdles to your wireless communication. And in such an environment, it's even more important to have a reliable and a high quality network. What else are we having in such a factory environment? Thinking about a factory, you have the topics like security. You have to secure your factory. And if your factory is based on communication of a network, also that network has to be secured. Reliability. You might have heard about the 5 nines or the 6 nines scenarios, which talk about how much downtime is really allowed in a factory environment. And the downtimes we are talking about is something like 31 seconds per year, which is not a lot if you think about how long 31 seconds are. So all of these requirements, together with the latency requirements that we need for the collaborating robots or the AGVs, are coming into the game as well. And network testing really helps to ensure that we can reach the expected quality of such a network. So we discussed about before how the network quality is determined in a traditional network. And taking the additional aspects into account, the quality requirements for a private network and in a factory scenario are way more tougher compared to them for a mobile network that's operating. So looking at the different tests, how to ensure that quality. You of course start with the rollout preparation. You do spectrum clearance testing, you do interference hunting testing to ensure when you deploy the network, everything is up and running smooth. This is then followed by the site acceptance testing, a lot of functional testing, RF signal verification. And this is then, of course, followed by the coverage aspect testing. So this is where you typically do the performance testing, you optimize the network, you ensure that you have connectivity at all the different places in the factory. And last but not least, this is also when it comes to the monitoring. So when everything is in place, you have the factory, you have the devices, you have the communications, you have to ensure to monitor real-time the quality of experience in such a setup. You can imagine you collect a lot of data that has to be analyzed. So also techniques like artificial intelligence or machine learning are supporting the analysis here and are taking into the algorithms. And if you remember our network life cycles, the steps we have here are quite comparable to that. But one important aspect we have to talk and we have to cover, and this is really the quality of experience. So remember, the quality of experience in a traditional network is based on your and my experience. How is this in a factory environment? How is a robot experience and network quality? He's not doing video streaming. He's not doing phone calls or social media activities, but he's having certain different requirements when it comes to data rate. He's moving around, so he's more interactive. He has real-time requirements towards the communication. Think about augmented reality, virtual reality scenarios where you need to have also coverage and you need to have sufficient coverage in a factory. All of these aspects and the complete non-human types of interaction, leading into, in addition to a network performance scorer, we have to define and specify what we call an interactivity test. And that interactivity test is a test, it's getting used for all different types of interactivity, not just in the factory environment, but it's dominated and it's calculated out of the bit rate, the latency, and the continuity. So the reliability also comes into the game for that. I brought a couple of examples where you can see, depending on the scenario where you are having the interactivity score, you can still have a good or a less good ratio. And it's taken into account what kind of scenarios you are having. So let me compare the VR retail shopping with the robot control. You see a robot is having, the blue line, a completely different latency requirement, a way more strict latency requirement than compared to a VR retail shopping or even a VR scenario that you have in a factory. So the way how you determine the interactivity, it's not just a generic model to combine the human and machine use cases. It also has to be adapted by the use case that we are having it here. And coming more towards the end, this is just a snapshot of the challenges we are facing and everyone is facing when deploying a private 5G network in a factory and also in a business or mission critical environment. All of the solutions I'm talking about here are reality today. The solutions are available. The testing is happening in all the different phases. And one aspect I liked a lot Joe brought up before, and this is why I think this forum is so important, because it's not just about having the right equipment. There it's also about being together and partnering with the key players in the industry, really to exchange about the challenges that we are having. We are all having the same challenges and we all have to find a way to overcome it. But really learning together what are the challenges we are having and how to overcome them is bringing all of us forward. We have worked together with many industry players also. There is a nice video you can find on YouTube about a factory setup. Bosch, Nokia, Rohde and Schwarz work together and doing 5G testing. And also in our own production lines, of course, like I said before, we are trying out our measurement equipment. That puts us into a unique situation that we can try and experience this by ourselves. I'm very happy to also get questions from your side. And if you have any further topic you want to discuss or you want to reach out or learn more about it, please don't hesitate to contact me. You find me on LinkedIn and also on the different spots. So it was a pleasure to be here. And Joe, over to you.
Thanks so much for that, Anne. That was great to hear. Again, with both yourself and also Fawad, partnerships came up again. And also, yeah, I think it's really interesting to see how the testing may change depending on the use case. We can deliver so many potential use cases with 5G. So thank you so much for that. Okay, I'm going to stop sharing my screen as we go to the questions. We have around 5 minutes left, so we'll not have time for all of them, unfortunately, but we can take a couple of each. And if Stephan and Fawad, if you'd also like to put your cameras back on, and let me try and get a question to everybody, and then for everybody that's listening in, we will capture the answers offline, and we will publish these when we share the video recording for everybody. So let's go back up to the first one, and I think Fawad, I think this is for you. Let me find it. Okay, it came in from Patrick from Airbus. How do you manage SIM card configuration and tooling with private 5G and public infrastructure?
Thanks, Joe, and I'll be quick on this response. So I think I would even go towards next part, which is actually eSIM is coming through as a technology to be used in IoT, and our configuration chain and tooling. Means there are many tools available depending on which technology vendor you select. But then working with a technology partner in this space with eSIM capability that can actually provide roaming to a public network, securely provide roaming and interoperability. This is we are already working on, so we'll be happy to address that. But there are also many others too. But if you, I can give you a detailed view later on that. So reach out directly to me. And yes, the challenge is what I would say is as there will be more IoT devices in manufacturing, the eSIM enabled IoT devices would become more crucial. And I think SIM card would is the right part to start for the POC, but I would suggest to look at the eSIM technology and explore that option. So
Great, thanks, Fawad. So I'll move directly on to the next one then, and this was for LACROIX. There's actually two questions, so I'll let you choose, Stephan, which one you want to answer. It was around how did you go about defining the 5G use cases that you wanted to test, and how did you build your partnership? So I guess they may be quite related, but I'll let you choose the answer.
Yeah, I really tried to answer the partnership question on the chat, right? Okay, the one from Malik. So let me answer the one on use case, because it's quite important as well. And I think Fawad has a better setup that I can present. My experience, and to add what Fawad presented. ROI is key for sure, but sometimes it's not so easy to be defined. But if you get an ROI on a use case, then it's pretty easy part. However, what we need to do, and my big advice is to get design thinking type of session where you get many ideas about what will become my tool or my manufacturing or my whatever assembly line, everything, and to mix people together, right, from the work floor, engineers and everyone, and then you get a lot of ideas, and from these ideas then you can refine about what can be addressed by 5G. We got an idea, for instance, just to share with you, that if people say, okay, if we have 5G, because people had in mind that 5G will be there as an experimentation, why don't we replace all our decked phone and everything with a 5G, right? Which was a great idea, but we didn't apply on this one. So you can run you can have a very nice ideas coming out of that, but you need to connect this, and you need to educate people about 5G as well.
I would want to add to this, and you brought up right, like the decked phone. The one thing I would say, one manufacturer was using LoRa technology to do inventory call up on certain things. And they were using it, and they say, hey, you just push a button and you get the inventory at your desk. But then, hey, I want AGVs to bring the inventory. So you add up the technology. Okay, how I move my push button that is running on LoRa to 5G? Oh, you don't need to move because we don't have that. So we'll move it in 2 years down the road. So I think it all comes back to bringing the right set of factory floor, the operations, and the telecom expertise, because they would know what capabilities 5G has and how to mix those towards the real challenges. Great point. Thanks, Stephan.
Thanks to both of you. Actually, I think that leads nicely on to the next question, and Anne, maybe you want to take this one. So there's a question from Devin that said 5G makes sense for specific use cases such as AR, VR, computer vision, OT/IT integration, but the module cost and battery drain is not ideal for all. For example, asset tracking. Do we believe that 5G is the answer for everything, or will it coexist with other solutions? So, Anne.
That's a great question. I would be so happy if 5G would be the answer for everything, but I think I see all of us smiling. Unfortunately, this will be like in previous technologies, right? So it's always a coexisting of different technologies. You manage the battery drain. We had that in WCDMA. This brought and this pushed forward the IoT technology development because it was not ideal. So I think also every technology has really key advantages when you choose that technology, but also it would push forward to other technologies. And already 6G is in the discussion. Many things are moving already from 5G to 6G, and they are going to getting deployed for 6G. So for me, it's always a coexisting of the technology and really choosing the one that fits best to the use case. And for us as a measurement vendor, measurement equipment vendor, we are also having a neutral position there, right? So we really observe the technology as a technology with the pros and cons that's bringing. And this means specifically for the industrial use cases, yes, definitely 5G brings in great functionality for the latency, for the data rates and so on. But also looking at the maturity of 5G, if you're comparing with Wi-Fi, Wi-Fi has a better maturity at the moment in that area. So it will be a coexisting, and it will be depending on your use case, when is the right timing for you, for what technology to decide. And we are lucky we have a couple of technologies to choose from.
Yeah, wireless, what we would advise also as a complementary of 5G is a Wi-Fi 6, not Wi-Fi for sure, but Wi-Fi 6. I think, and you agree, right?
Yeah, definitely.
Fabulous. Thank you. Listen, thank you to Anne, Fawad and Stephan for joining us. We're a little bit over time, so sadly I'm going to have to close this, but thanks to everybody that's joined us today. It's great to see lots of questions coming in, and I think we could have probably gone on for at least another half an hour, maybe longer. But I'd like to, thank you all for joining us today, and would like to sign off and say goodbye. So thanks very much. Thanks for everybody.
You.
Bye-bye.
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 Bye-bye.